Okay. And in fact, I think what I want to do is, I think the last problem that we did, okay, I just had it and I was looking at it. Here it is. The last problem we did, I think, was on page 20. Is that right?
Yeah, it was E.
Yeah. So I think what I'd like to do is just go back through that problem. I know we've already done it, but I think it would be good for us to just kind of go through something familiar before we jump into a brand new problem. So let's do that. So just a refresher about what we need to put into our picture. This problem is all about graphing. So what are some of the things that we have to put into our picture? Who remembers? Or look at what you already did. What do we have to put in?
Asymptotes.
Yeah, we gotta put in some asymptotes. And you're not gonna be able to put in your asymptotes until you do what to your problem? What are we gonna do first with our problem?
Factor.
Yes, thank you. We're gonna factor this guy. Yeah, we're gonna factor it. So here we go. How does the top factor? Anybody see it?
X minus 5, x plus 1.
Yep, x minus 5, x plus 1, perfect. That's how it factors. Remember, you can always check if you're not sure by foiling it back together and making sure it gives you that. This does, good work. What about the bottom? What about the bottom, guys?
You take out a 2.
Yes.
And you get x minus 2 and x plus 2.
Yep, so the first thing we're going to do is pull a 2 out of that. And when we pull a 2 out, it leaves us with x squared minus 4, which, as she said, is x plus 2, x minus 2. Now, sometimes when we do all that factoring, things cancel out. But nothing's going to cancel this time, is it? So, we're going to step over here to the graph. And here we go. What are we going to put in this graph? Well, someone mentioned asymptotes a minute ago. Where will the asymptotes go?
Do you say it equal to 0?
The denominator. No, that would be the intercepts. We're going to find those in a minute too, when we put in zeros like this. But those are points. Someone mentioned asymptotes at the beginning, and those are lines. So the vertical, yeah.
So you put in the asymptote.
The vertical asymptotes come from the denominator of the fraction. What would make this 0?
2.
Well, this one it would be 2. This one it is negative 2. So we're going to have 2 asymptotes this time because there's 2 x's in the denominator. So that gives us 2 vertical asymptotes. Okay? Now, where's the horizontal? What?
No, I had a question. How do you got negative 2 and 2?
It's what makes the denominator 0.
Oh, I see now.
Yeah, you need to make a note of that. We learned that a long time ago, and it's time for us just to know that now. So make a note. Vertical asymptotes come when the denominator is 0. Now, what about my horizontal asymptote? You're supposed to know this too. Where does it come from?
It's the x squared.
Yep.
And 2x squared.
We just box this in right here. I like to do it in the original problem. I think it's easier there. So where would that asymptote be? If we have 1x squared over 2x squared,
At 1/2.
yep. So we're going to have a horizontal asymptote at y equals 1/2. Now, we also do need the intercepts. Somebody mentioned these earlier. The intercepts are points, and they're points where something is 0. So, if we do this one first, and it does not matter which one we do first, if we do this one first, we're going to plug in a 0 for our x's, right? That's in the x spot. So we're going to plug in zeros for our x's. We can do that here, or we can do it in the original problem. I like to do it in the original problem because there aren't as many x's. If I put in zeros here, all I have left is -5. If I put in a 0 here, all I have left is -8. So it looks like I have the point 0, 5/8. All right, now I'm going to let y be 0. So now I'm going to come over here to this equation right here, and I'm going to let y be 0. I put 0 over 1 so that I can cross multiply. Kids, it's super simple. What is 0 times anything?
0.
0. So when I cross multiply, that's just 0. And then what's 1 times anything? Just itself. So what are the values of x that would make this 0? What makes this 0?
5.
Yep, and we got 2 of them.
-1.
Yep, so we have 5 and -1. There's 2 of them that we get when we put 0 in for y. So I'll plot those points. So there's 5, and here's -1. Sometimes these problems have holes. This one does not, because nothing cancels, right? So now I need to sketch in my picture. Now remember, we got these 2 vertical asymptotes. They split your paper into 3 sections. You have the section over here on the left, you have the section in the middle, and then you have the section on the right. Now, these 2 points are both in the middle section, so they have to be connected. So when I connect those 2 points, that's the shape I'm going to get. Now, someone asked me the other day, Mrs. Ford, couldn't it look like this? Couldn't it do something like this? And the answer is not this time. It absolutely could in certain problems, but not this time. Because if it did this, I would need to have a point plotted here, wouldn't I? Like I have that one plotted, wouldn't I need to have another one over here? And I don't. You cannot create new intercepts. The only intercepts you have are the ones you found over here. So this cannot turn around, it must just keep on going. Whoops, wrong color. All right, now what about on the left and the right of the picture? Well, here you got a clue, you got a point here. So the curve's got to go through that point. So you have one of your, I don't know, what do we call that shape right there? You have one of those? What do you think's gonna happen over here on the left side? Do you think I'm gonna draw something in the top corner or in the bottom corner?
On the top.
Yes. And it has to be on the top for a couple of reasons, but really the biggest reason I think that makes sense to you guys is you know that when we graph these things, the pieces are like across from each other, like diagonally across from each other. So you have this down here, that's part of your graph. So you go diagonally across from that, not next to it. We're not going next to it, we're going diagonally across from it, so it needs to be up there. And that is a picture of that curve. And I know we already did that, but I think it's good to get warmed up with that one. Because now we're going to tackle the next one, which looks very similar. So how do we start? Oh guys, come on now. How do we start?
Find your asymptotes.
And we find, very good, and we find our asymptotes by doing what to the bottom? What are we gonna have to do to the bottom? Factor it,
Factor.
very good. And how does that bottom factor?
What number are we on in the handout?
We're on page 20, doing problem E.
Okay.
We just did D, I don't know what's going on there.
Is it 3 and 1?
It is 3 and 1, x minus 3, x plus 1. Again, nothing cancels, which is fine. That just means we will have no holes. Eventually, we're going to have a picture that's going to have some holes, but this one doesn't. But it does have 2 vertical asymptotes, doesn't it? What are its vertical asymptotes?
3 and -1.
Yep, x equals 3. Remember, we're labeling those. X equals 3 and x equals -1. Now, this one's a little tricky with the horizontal asymptote, because when we do a horizontal asymptote, we have to compare, remember we box in the highest powers. What's the highest power in this problem?
Squared.
Yeah, and I don't have any on the top, do I? So when I box those in, I get 0 over 1. And it's been a long time, but you might remember that when the power on top is smaller, the asymptote is always at 0. When the power on top is smaller, you're always going to get 0 over something. So anytime, doesn't matter what the numbers are in the problem, anytime the power on top is smaller, you're going to have a horizontal asymptote at 0. If you don't remember that from when we talked about it before, that might be something to write down. All right, now I'm going to come back up here. Let's do our intercepts now. That's all the asymptotes. So we're going to start plugging in zeros. So if I put in a 0 for x, this point says x is 0. If I put in a 0, I have 5 over -3 times 1, which is what? What is that, guys?
Is it -5/3?
Yes, it is, -5/3, very good. So I'll come over here and I'll plot 0, -5/3. Now remember, if you're having trouble figuring out where to put that number, remember you can make it a mixed number. So that would be 1 2/3. So it's in between 1 and 2 here. -1 and 2. All right, now I'm going to put a 0 in for y. I like to put 0 over 1 so I can cross multiply. So 0 times anything is 0, and 1 times anything is itself. So what is this x value going to be? What's that x value?
-5.
Yep. So that's -1, -2, -3, -4. All right, this one's a little bit tricky. Little bit tricky, but I think we can figure it out. Again, we have 2 vertical asymptotes. So you got to figure out, you got to draw something over here on the left, something in the middle, and something on the right. Claire, are you having issues there, dear? Everything okay?
Oh, sorry. I'm having internet issues, so I was here in the beginning of class, but
I
then
know
it
you were.
took me out.
Yeah,
Oh,
okay.
okay.
All right, yeah, I know, I had you. Okay, now, here's what I want you to remember. When you're graphing these things, anything, when you're graphing anything, you cannot cross the x-axis anywhere but here. That is your only x-intercept, right there. That's the only place you can cross the x-axis. And this is the only place you can cross the y-axis. You cannot cross vertical asymptotes ever. So whatever you draw, you're not gonna go from here to here, for example. You can't connect those because you can't cross. These are like walls. All right, so does anybody have an idea about any piece of this picture? It's kind of a tricky one, but maybe you have an idea?
Is it in the middle, like the last one, a wiggle line?
Well, it could be, but it's not, because he said wiggle line. If we make like a cuting thing in there, you can't, because if you did that, what would you have to do right here? Wouldn't you cross your axis right here?
Yeah.
And you're not allowed to. So guess what? We got something like this in here. Remember, you're only allowed to cross the axis right here. That's the only place. So you're not crossing the axis over here either. Any idea what shape we've got over here? Keep in mind, you've got you drawn down here. Where do you think you're going to draw over here?
Top right.
Yeah, absolutely. Because remember, we do across from each other. Well, wait a minute. If we do across from each other here, where do you think we're drawing over here? Same thing? Yep. And this one is tricky. There's no question about it. Because normally it does what this does. Normally it just follows the line out. This one actually crosses the line and then follows it out. That's a much harder question than I would ever put on a test or quiz. It's good for us to practice those, but I'm not going to
So
grade
how are we
you on
supposed to
that.
know that though? Like know that it's gonna be a U shape?
Where in here?
Yeah.
Okay, you need to know that because you need to ask yourself, what else could it possibly be? Remember, you cannot cross the axis anywhere but here. So you cannot cross that line. But the curve has to contain that point. There are no other possible shapes, right?
Yeah.
Yeah, that's it. So the part of this that you absolutely have to know is, when you find these intercepts, those are the only places you're crossing an axis. So whatever you draw, it cannot cross an axis except at those points. That's why we find those first, because that helps shape our picture. All right, let's try the next one. I think it's gonna be a little easier. Nothing tricky in this one, I don't think. All right, so we have, done a couple of them now this morning. So, how do you think we'll start this? What would be the best way to start this?
Factoring.
Thank you. And does anybody want to volunteer the factoring for this? It looks like we can factor the top and the bottom. Anybody want to take a stab at it?
X minus 4, X plus 1.
X minus 4, X plus 1 on the top. I think she's exactly right. She needs to multiply by 4 and add to -3, and that's what she did. Perfect. And then the bottom, guys, that's a no-brainer. We've done a zillion of those. What's on the bottom?
X plus 1, X minus 1.
Yep. Perfect. Oh my, what do you notice?
Can cancel something out.
Yes, we can. So what we're ultimately going to graph, kids, is just this, because those cancel out. But do you remember from before that when something cancels out, we end up with a hole in our graph? And do you remember, look at what canceled. What is the x-coordinate of the hole going to be?
-1.
Yes, indeed. Why is the x-coordinate -1? Because that's what I canceled out, right? Now, how do I find the y? Notice this is a point. I'm going to plot that. I'm going to put that on my picture. I need a y value. How would I get the y value?
Plug it in.
Plug it in right here. Plug it in your new problem. This is what we're graphing now. So we're going to plug it in there. So if I plug in -1, I'm going to get -5 over -2,
Yeah.
which is 5/2. So I'm going to come over to my graph, which is 2.5. That's 2.5. So I'm going to come over to my graph, and at -1, 5/2, I am going to put an open dot. That's called a hole. It's just like a regular point, except it's open. Why haven't we had any holes in any of our problems up to this point?
Nothing can.
Yeah, nothing canceled out. The only way you can get a hole is if something cancels out. You're exactly right. Good. Okay, well, let's look at what's in the box here, and let's put in all the rest of the stuff, our asymptotes and intercepts. So anybody tell me anything about the asymptotes of that? Remember, you're looking here now. What are the asymptotes? What's the vertical asymptote?
1.
X equals 1. Vertical asymptotes are when the denominator is 0. So that would be at 1. How about a horizontal asymptote? Where's my horizontal?
1.
Yes, very good. We're going to box these in, right? So we have x over x, which is 1. By the way, would we have gotten the same thing if we'd have boxed in the original problem?
Yeah.
Yeah. All right, now we need our intercepts, so we're going to put zeros in different places. Remember, we're putting them right here. This is where we're putting them. So if we put in a 0 for the x's, that's what this says, x is 0, we get -4 over -1 or 4. Everybody following that? Now I'm going to let y be 0, or 0 over 1, and I'm going to cross multiply. So 0 times anything is just 0, and 1 times anything is just itself. So when I solve that, do I get x equals 4 also? Can you sketch in the shape, people? Can you see, knowing everything you know and having these dots and stuff, can you see a picture? Can you see this arc thing right here? Notice that it's going to go right through the hole. It kind of skips over that point. That's an opening in the picture. But it's a nice smooth curve picking up that point too. And then where's the other piece of it going to be? Top right, bottom left. Or, I mean, top or bottom?
Bottom.
Bottom, because there's a point down there, right? And we want to be opposite the one we already drew. So if we're up here on the top left, we're going to be down here on the bottom right. All right, so that one is a little easier. There's really nothing tricky going on in that one in terms of the shape anyway. Would you agree? That one makes sense? All right, well, I think we have one more. So I'm going to take a minute and let you try to get it factored, because by this point we know that step 1 is factoring. So you've got to get it factored. So go ahead, see if you can get problem G factored. Anybody have either piece factored, top or bottom? I hate to just call on people, but that's what I'm going to do if I don't get some volunteers.
I don't know if it's right, but I put 2 in the front of the parentheses.
Out here?
That'll be 2. Yeah.
Okay, that, we can't do that because if we did that, we'd be factoring a 2 out of our problem. So if we had a problem that looked like this, we absolutely could do that because we can take a 2 out of the whole shebang, but you cannot take a 2 out of the whole thing. So the 2 is not going to be out in front. It's actually going to be in the parentheses.
Okay, so it'll be 2x minus 3 minus 2.
I'm going to put the minus
minus
3
2,
here
yeah.
and the plus 1 here. And here's why, guys. When I foil this, and that's how you gotta think about it as a foiling problem. When I foil it, I get 2x squared minus 6x plus 1x minus 3. What do these two add up to? -5. And there's my minus 3. So whatever you put in the front has to give you 2x squared. Whatever you put in the back has to give you -3. And then in the middle, when it foils, it has to give you -5. All right, now what about the bottom?
X minus 3, X minus 1.
Yep, perfect. And again, if you FOIL this together, x squared minus x minus 3x plus 3, it gives you exactly what you wanted. There is no mystery to factoring. It's very logical and trial and error. You can figure it out. All right, but what do you notice now? We got it all factored. What do we have?
A whole.
Yep, we're going to have a whole because our problem reduces to this. This is all that's left. But because we canceled, we know we're going to have a whole, and where is that whole going to be?
-3.
Yeah, where x is 3, yep. And then, because I'm going to plot it, I need a y part. I'll just come back over to my equation and I'll plug in 3. So if I plug in 3, it looks like I get 7/2.
Yeah.
So I'll plot the point 3 7/2. And remember, if you have trouble with your fractions, think of that as a mixed number, 3 1/2. So that tells you where to plot it. And of course, our pictures aren't perfect, but we want to get it sort of in the right spot. There's our whole. Our open circle is at 3 7/2. All right, now come back to the problem, the new problem, the reduced problem. Tell me about asymptotes. Do we have some asymptotes in there?
Yeah.
Where?
Y equals 2.
Y equals 2, very good, and he got that. That's our horizontal, and he got that by boxing in this right here.
Yeah.
All right, what about a vertical? Do I have a vertical asymptote? Guys, where do vertical asymptotes come from?
1.
Yes, it's x equals 1. Vertical asymptotes come from your denominator. What makes it 0? 1. All right, now I need my intercepts. All right, so let's plug in 0 for x. All right, so what happens if I put in 0 for x? I get 1 over -1, -1. Is that right?
Yes.
And now I'm going to let y be 0. I'm going to do this point now. I'm going to let y be 0. So I'll come back over to my equation. Think of it as 0 over 1. Cross multiply. Here we go. 0 times anything is 0. And 1 times anything is itself. All right. Solve that little equation. Very good. It's -1/2. Very good. Subtract 1, divide by 2. -1/2. So that's right here. All So here we go. Can you visualize what it looks like based on the framework that you've established here? Hopefully you are connecting these dots right here, like that. And then you got a piece up here in the opposite corner that contains your whole. Now, is there anything about that problem that you found confusing? We're not confused? All right, that's a pretty straightforward problem. That one and the last one we did are pretty straightforward. So, we'll be having a little quiz over that. So let's practice another one. This is not in your packet, so do you have just a sheet of paper somewhere that you could write this down? And I'm going to give you about 5 or 6 minutes to see how much you can do all by yourself. Now, you can use your notes for now, but let's see how far you can get with this picture on your own. Here we go. All right, so jump in, put in wholes, asymptotes, intercepts, and draw your picture. I'm not going to help you. I'm going to hang out here and wait a minute for you to see what kind of progress you can make.
Gabe, can you mute yourself so I can see the screen?
Yeah, my bad.
Tell me if you think you got it figured out, and we'll walk through your solution. Chase, got to see your face, buddy. William, Courtney, Nate. Nathan McCahill, are you there? All right, let's stay on screen, please. Stay focused on our math. Essence. Did you get it factored, Essence?
I did, Miss Ford.
Okay, I need to hear from Essence though. Essence Smith, you got it factored?
No.
Uh-oh. Uh-oh.
Is it x minus 1, x plus 1, and x plus 1, and x minus 3? Or is that wrong?
Well, the -3 part is wrong. The top part was beautiful. And the bottom
wait.
part started
That
out
was
beautiful.
-3. Sorry about that.
I think it's x minus 7.
Yeah, it's minus 7.
Yeah.
Let me plus 3.
Yes, so that's the factorization. All right, you need to be able to get that started, that far, guys. Is everybody, does that make sense to you?
The whole problem. Yeah, I have that.
You had that? Okay, yeah. All right. Yeah, good. That's step 1. Now, you gotta pay attention. What happens in this? What do you notice?
There's a hole.
There's gonna be a hole because these are gonna cancel, right? So our problem is really going to be just x minus 1 over x minus 7. But the fact that we canceled means we're going to have a hole where? Where is that hole going to be?
-1.
Yep. And then of course, you're ultimately going to be plotting that, so we need a y value.
Is it 3?
Well, I'm going to put -1 in here, so I'm going to have -1 minus 1 over -1 minus 7.
Is it 1/4?
Well, let's see. -1 minus 1 is -2. -8, yes, 1/4 is exactly right. Whoever said that, you're right on target. 1/4. Remember, you're just plugging in -1 in the x spot. So -1, 1/4 is my hole, so it's right there. All right, did anybody get any further than this? Did anybody get an asymptote maybe?
Y
I got
equals
the horizontal one.
Okay,
Horizontal one.
what's the horizontal one?
1.
Yep, y equals 1 is your horizontal asymptote. Guys, don't be confused. Look, you have x over x, right? Or if you go back to the original, you have x squared over x squared. That's 1. That's 1. All right, what about a vertical asymptote? Anybody get one of those?
Is it 7?
It is 7, x equals 7. So I gotta count clear out here. 1, 2, 3, 4, 5, 6. Here's x equals 7. Now your asymptote's way out here. So you got something here and something over here. All right, how about intercepts? Did anybody get an intercept, either by letting x be 0 or y be 0? William, this is easy. If you go back to that box right there and you put in zeros for x, what do we have?
1/7.
Exactly. I'm not sure that was William, but that's exactly what we have. -1, -1 over -7, so 1/7. So my y-intercept is right here, 1/7. I know you don't like the fractions, but it's no big deal, guys. We're not being super picky. Okay, now what about if we let y be 0? If we let y be 0, zero over 1?
1.
So here we go. Yep, we get 0 equals x minus 1, 0 equals x minus 1. So it's at 1, 0. Now, on the basis of that, can you connect the dots? Can you get a picture out of that? Your vertical asymptote is the divider, so you got to graph something on the left side of it and something on the right side of it. See these points right here? What are we going to do with all those points?
Go through them.
We're going to connect the dots. Yeah, I love it. We're going to connect the dots. So here I go. I'm connecting the dots. And I got to come clear over here because this is where my asymptote is. Clear over here. So I got to bring it all the way to here. Now that's only half the picture though, because you have taken care of the left side of the asymptote, but what's going on over here on the right side? What do you think's happening over here on the right side of the asymptote?
Join it on the top.
Yep, right up here on the top. Perfect. The same kind of shape, but up there on the top. All right? Now, if any of that is bothering you, then please, please, please think about coming to Flex and practicing with us so you can get better at it. Okay? All right, well, it's time to go, guys. So I will see you, I don't know, maybe tomorrow, maybe the next day, I don't know. And we'll practice one more time before we take a quiz, all right? All right, love you guys. You're welcome. Bye. Bye. See ya.
How did you like that test score?
Huh?
How did you like that test score?
Loved it. Loved it.
Alright.
We'll see ya.
See you later.
Bye-bye. Chase? Chase? Chase Johnson?